Hi, and welcome to the third in our webinar series, Connection Regardless of Location. This session will focus on coverage inside tunnels. My name is Sam Dilley, and your speaker today will be Moti Shalab, one of our product managers here at Axel Wireless. We've got a very interesting webinar for you today. Just before we start, I have a couple of housekeeping points to make. During the webinar, you will be placed on mute to avoid any feedback and to ensure we finish on time today. If you have any questions for Moti, please send them via the chat option, which you should see on your right-hand side of your screen, and we'll get through as many as we can at the end of the webinar. Okay, over to you, Moti.
Hello, everybody. I'm happy to be here with you again. Our topic for this session will be the coverage inside tunnels. A few words about our agenda. So a short introduction about Axel Wireless, then why we need the tunnel coverage, several solutions for tunnel coverage, and very interesting case study from a project that we did in Australia. And of course, we leave some time for questions and answers. So Axel Wireless has been in the industry for the last 40 years, a very long period. Basically, is a global developer and manufacturer of DAS, distributed antenna system solutions, and wireless coverage solution. Axel has now become a part of a Cobham. It's a big company, annual revenue of $3 billion US per year, traded in the London Stock Exchange, and Axel now has become, in the last 1.5 years, a part of Cobham. The main focus of Axel is quality and technological innovation. We have offices all over the world, around 250 employees, selling in 150 countries. And in the latest research done by ABI, this is a leading analyst firm that has multiple offices all over the world, Axel Wireless has been named number one due to innovation. This is basically due to a new platform that we've launched half a year ago in the Mobile World Congress show in Barcelona. And overall, Axel Wireless is number 3, which is very impressive. Now we touch base with the main topic of this session, why we need the tunnel coverage. It's very, very simple. Basically, if we look on wireless signal, they cannot penetrate into structures such as tunnels. So again, if you will not have a dedicated coverage inside the tunnel, it will be very, very hard to get any signals there. And of course, everybody that is using the tunnels, no matter if that's a train tunnel or car tunnel, everybody expects to get coverage when they use this service. And when we're looking about the operators, the transportation operators or tunnel operators also, they have a requirement to provide coverage for their own staff and also for drivers in case of emergency happens. So again, without a dedicated coverage inside the tunnel, all of that will not happen. We will see later on some different structures and how we provide different solutions for tunnel coverages. Again, if we look from a different perspective, so of course, if I'm a traveler, I want to get a connection to be able to handle my voice call, email, text, etc. And also, in case of emergency, that's the main feature, audio break-in. We'll touch base of that in a couple of slides that provide messages through FM car radios. If I'm the mobile operator, of course, I want that my customer will have a lot of satisfaction due to continuous network availability, and sometimes also can increase the revenue, especially on roaming users. This is like a good example is a tunnel that connects between two countries, like the Euro tunnel between the UK and France, where a lot of roaming users use this service. And if I am the tunnel owner or operator, again, very important to make sure that the satisfaction of my customer is increased, and they will choose to use this tunnel. In some of these tunnels, you need to pay money to access these road tunnels. So again, very important to make sure that they have very good coverage within this route. and of course to make sure that the safety of the travelers is being remained. So when everybody is using the tunnel and in case of emergency, still very good communication within the tunnel without any interruptions. When we look on tunnels, there are a lot of things that we need to take into our design. It's basically the first thing is to make sure what are the frequencies and the services that are required. Do we require, normally in tunnels we need at the minimum public safety services, but today tunnels will have cellular or mobile services as well. So we need to define the frequencies and the signal strength that's required. The length of the tunnel, of course, impact the solution that we use. It could be off-air BDAs or fiber optic. We'll see later on some examples. A different type of radiating elements within the tunnel. Is that a leaky feeder cable or antennas? Where to put the equipment inside tunnels. Sometimes that could be a very, very big challenge, especially in old tunnels, you know, tunnels that has been built very long time ago. They didn't plan to have communication room within the tunnels. Today, normally when you look on modern tunnels, they know that they must build communication room, and it's much easier to find places for the equipment. So, but in all the tunnels could be a big challenge. And very important is redundancy. When we're talking about installations inside tunnels, could be a very challenging thing, you know, especially sometimes you have very limited window to access the tunnel. So redundancy becomes a very important thing, especially when we install equipment inside tunnels. Let's take a look on multiple type of solutions that can be installed inside tunnels. First of all, which normally, this is the normal solution that we install inside tunnels, is an optical DAS, distributed antenna system. This is normally required due to the length of the tunnels. So if you're talking about tunnels that exceeds few hundred meters, 500-600 meters, normally that could be the preferred solution. And another solution, and also could be a combination between off-air solution and optical DAS solution. That's off-air normally for a shorter tunnels, so where, you know, a optical off-air BDA can do the job. That could be also a valid solution for tunnel coverage. And basically the way to propagate the RF signal within the tunnel, we have two basic architecture. One of them is leaky coaxial cables, and the second one is antennas inside the tunnel. So if we take a look on a optical DAS solution, basically, as can be seen in this slide, we have one location where we normally co-locate all the base station of all the operators, also if that's a public safety service, everything is co-located together normally. We call, by the way, the name of this concept is called base station hotel. So we take one location and co-locate normally all the base station. This is very important from the maintenance perspective, which makes life much easier. So the technician, in case of something happen, will go to one location and just do the maintenance that is required. Within this base station hotel, we co-locate the optical master unit, OMU. Optical master unit is an element that takes the RF signal coming from all the base station and basically convert the RF signal into light. Then we have a fiber optic cable going all the way, basically up to 20 kilometers from this base station hotel, to remote units, which does the opposite conversion, takes the optical light, basically convert into RF on the downlink, and of course on the uplink, the opposite, takes the RF signal coming from the mobile or handset and convert into light. And these remote units provide all the amplification that is required, and basically the output of these remote units is RF signals that are propagated within, in this example, it's a leaky cable, but could be also using antennas. So again, base station hotel connected to an OMU and fiber optic going to remote unit, which propagate the RF signal via leaky cable or antennas. Again, as I've mentioned before, it provides a big advantage using this concept, a base station hotel, that's minimize the operational and capital expenses of all the operators, because it saves space, you collocate all the equipment together, and then it's much easier in case of that you need to maintain or upgrade the system. That's very, very easy to go to one location and do it for all the operators. If we take a look on an off-air solution, basically this is an off-air solution that is feeding fiber optic DAS solution. So basically an off-air solution is an idea to have a BDA or a repeater that takes pick up the signal from its donor antenna from the base station. Then this BDA does all the filtering that's required, whatever is required, and then basically provide the RF signal into the OMU, into the optical master unit, and then it's the same system that we have discussed before. Again, this is a solution that gives you, instead of connecting to the base station, basically you have an off-air pickup of the signal and distribution using fiber optic DAS system within the tunnel. Let's take a look on two different architectures which are normally used in tunnels. Let's take a look on sort of antennas. We all know antennas. This is an example of a Yagi antennas, but different type of antennas can be used to provide the coverage, the RF propagation within the tunnel. This is, again, of course, the cheapest solution, relatively easier to install. And still, in some cases, this could provide can give a big challenge, especially again from old tunnels that have not been designed to put a lot of elements, or then to put antennas could be a big challenge, because just from the height perspective, etc. And if we take a look on the alternative way, which is the leaky feeders, again, this costs more money. Yes, leaky feeders are more expensive than antennas. But at the end of the day, the coverage within the leaky feeder is much better compared to antennas. Axel Wireless has a worldwide experience from hundreds of tunnels all over the world that we've done with multiple services, including cellular, public safety, etc. And this seems the leaky feeder, this seems to be the most preferred solution whenever can do it. I know that sometimes either they don't have the budget or whatever to put the leaky, and then they get an antennas, and the solution is better with leaky. That's no doubt about it at all. Okay, so normally when we're talking about a remote unit, we need the remote unit to provide multiple services. So it could be, if we're looking on public safety services, could be FM services, DAB, VHF, Tetra in different frequency bands. So normally when we are taking these remote units, these are what we call broadband remote units. What does it mean? That the remote unit will cover the full band that we are talking about. If that's, let's say, VHF, normally it will be a remote unit that covers the complete VHF band. But then remember that you need the feeder to this remote unit or to the optical master unit is either a base station, so only designated channels that you want to propagate within the tunnel will be amplified and transmitted. So basically this is a very clear signal using a base station. Of course, you get only the channels that this base station will handle. Or if that's an off-air, again, normally what is being used is what we call channelized digital BDAs, digital repeaters, which again provide you very clear signal, very clean signal, to make sure that you only the channels that you want to amplify within this system, the optical DAS system, will be amplified through the tunnels. So again, that's something that we need to remember. So if we look on the fiber DAS remote units, normally these are broadband, which are wideband. And when we're talking about the off-air, normally these are channelized solution. That's what we are using. Or, of course, base station, which are, again, channelized, provide you only the channels that this base station can transmit. Another application that is normally used in tunnels is sometimes in case of emergency This, by the way, an example on a RS1 VHF closed loop system. This is in case that you have an event inside the tunnel, emergency, and fire services, police services, whatever, want to speak with themselves, so they can have this what is called closed loop system, using this technology, using this fiber dust technology, basically to provide the emergency services within this tunnel. Another way to take a look on the complete system, that's basically a system that includes multiple solutions, VHF FM, VHF DAB, Tetra, and cellular. We need to remember that all these services, we need to put them into POI. POI stands for point of interface. The idea of this point of interface is basically to provide the correct or adequate level that is required by the optical master unit, provide all the combining all the services together. If you need specific filtering, that needs to be done as well. And then we get this optical master unit that takes the RF signal, again, as explained before, translate them into light, so RF into light conversion, and then this can feed multiple type of remote units. And then on the remote side, again, in some cases you will need to provide adequate filtering to make sure that you don't have interference from one service to the other one. And at the end of the day, propagation of the RF signals, we already know, can use either antennas or leaky feeder. So again, this is a sort of a picture that provides you complete architecture with the optical DAS system. And again, the feeder to this system, to the POI, can be either normally channelized off-air solution, channelized digital off-air solution, or base station. So both solutions, both feeders are valid into the POI. Another example of a MIMO, in some cases operators, normally that's only happens today with cellular operators, maybe in the future when LTE services will become common in public safety services, maybe they will consider that as well, is MIMO, multiple in, multiple out. So again, we can use, we have several solutions that can provide you a MIMO within the same remote unit. Just another variant of our multi-band MBF 40, that stands for multi-band fiber 40 dBm. So that's the power range of this solution, and that can provide a MIMO for cellular application within the same remote unit, just two separate antenna basically. Another critical feature, especially when we're talking about coverage inside row tunnels, is audio break-in. Again, in a case of event or critical situation, what is happening, the tunnel operators basically is using this service, this audio break-in service to provide into the driver's radio and provide notification. And they can deliver a message, evacuate the cars or whatever, if that's a fire inside the tunnels or whatever. So again, this is very critical, and normally in some countries all over the world, they will not be allowed to open any tunnel, any row tunnel, without having this feature. So this seems to be a sort of a mandatory requirement in some countries, that you cannot open a new row tunnel without having that. Basically, you probably can open the row tunnel without having cellular services. That can happen, you know. So if no one of the cellular operators care about coverage inside the tunnel, so they probably will not have, but they will not be allowed to open this without having this feature, audio break-in. So again, in some places you will find operators that have multiple tunnels around a certain location or country. So normally they will have a command and control center that will control all these tunnels, and again, we'll need to provide all these guidance using this audio break-in feature. Normally the frequency band that this is being used is FM, DAB, and VHF. These are normally the frequency bands that this feature, the audio break-in, is being used. Again, on the could be each one of the frequencies. Normally when we're talking about the drivers, of course, they will not have, the car driver will not have VHF receivers in their cars. They will have only FM radio, so that's mandatory to have the FM. Just example of our remote management system. Again, when you have a nationwide or very large system, you need to have a system that will do all the NMS and network management and provide all the alarms and the status of the system elements. Let's take now a look on a very interesting case study of a project that we've done. This is, by the way, an example that, of project that we've done in Australia. This is called the Brisbane Airport Link. This is basically the large road tunnel in Australia. It's not in the world, of course, but in Australia. We're talking about a tunnel of 15 kilometers with 25 bridges, you know, and that basically connects from Brisbane Airport to the city. So again, as we already know, without having a dedicated coverage within the tunnel, you cannot get any wireless coverage, not cellular, not public safety. And the task here, the project was basically to provide a multi-operator coverage within the tunnel for all the Australian operators, and of course provide a public safety coverage for the public safety utilities in Australia. The solution that we've used here is using, again, fiber DAS solution. We already know that that's the preferred solution within to provide the coverage inside tunnels. So we had 50 multi-band remote units for cellular operators, and then 40 for UHF and Tetra 800 megahertz. I don't know if you're familiar, but doing this cellular multi-band remote unit for the cellular operators in Australia is a very challenging thing, because in Australia and in some other countries as well, they have this mix of frequencies from Europe and the US. So they have the what is called the EGSM, or the 900 megahertz European band, and also the 850, the US band, which are only 2 megahertz apart each other, which, believe it or not, it's a very, very big challenge to make sure that you'll not have any interference between these two services, only 2 megahertz apart of the uplink of the 900 and downlink of the 850. So you can imagine that you need to provide a very dedicated filtering to make sure that this will work without any interruption. So again, it was a very challenging project to combine these services together. This customer has requested to have all the elements managed through Axel Wireless Element Manager. This is our element a network management system called AEM, stands for Axel Element Manager, that basically gives you all the alarm of configuration of all the elements, and also can be connected to a manager of manager a program or platform that and send a standard protocols such as SNMP to this platform, and give to a nationwide control center, network operation center, all the alarms and information from this project. Again, that's basically the benefit of this project, that provide the coverage both cellular and public safety. Again, when you think about these kind of projects, you need to do a lot of planning on day one. Why this is important? This is really important to make sure that this will be a future-proof system. And guess what? After a few years, after we installed this project, then the tunnel operator came to Axel Wireless and they told us, hey guys, I need you to support additional services within this tunnel. So again, we had to scratch our heads how to do it, but again, because it has been designed from day one on a very flexible way, it was relatively easy to integrate this service as well. So again, very, very important whenever you do designs or commissioning of such projects, you need to think about this future-proof, because if you need now to redesign a project, a tunnel project, believe it or not, that's a very, very big challenge. And if you need to reinstall cables, etc., that's, as we already know, a very big challenge.